Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus Physics SSC2 Unit number 12 Geometrical Optics. Today we will discuss about SLO base according to FBISC requirement numerical problem. Question number 14 to 17 in part 7. So first of all we will discuss question number 14. In question number 14 given statement an optical fiber is made from felt glass with the index of reflection is 1.666 and is surrounded by clouding made of bronze glass with the index of reflection is 1.52. What is the critical angle? First of all, write the given data. According to the statement, the reflective index of fluent glass, that is N1, is equal to 1.66 and reflective index of carbon glass, that is N2, is equal to 1.52. Now we can find that critical angle, that is theta c. According to the statement, sin theta c is equal to n1 divided by n2. This implies that theta c is equal to sin inverse n1 divided by n2. Putting the values, then theta c is equal to sin inverse 1.52 divided by 1.66. This implies that theta c is equal to sin inverse into 0.91566,265. Taking the sine inverse of this value, so critical angle is 66.3 degrees. Now, in question number 15, given statement is suppose that book page is hold with 7.50 centimeters from a convex lens with the focal length of 10 centimeters and concave length of the focal length is minus 10 centimeters. What is the magnification is produced in each case? So write the given data. Distance of object D naught is equal to 7.50 centimeters. Focal length of convex lens is equal to f, that is equal to 10 centimeters, and focal length of concave lens, that is equal to f minus 10 centimeters. Now required that magnification in case of convex lens m and magnification in case of concave lens, that is m. Now, first of all, find the distance of image in case of convex lens now using the formula. In this formula, we know that 1 upon f is equal to 1 upon d naught plus 1 upon di. This implies that 1 upon di is equal to 1 upon f minus 1 upon di. 1 upon 10 minus 1 upon 7.5, that is equal to 7.5 minus 10 divided by 10 multiplied by 7.5. This implies that 1 upon di is equal to minus 2.5 divided by 75. Taking the reciprocal on both sides, so di is equal to 75 divided by minus 2.5. So di is equal to minus 30 centimeters. Now we can find the magnification of the concave convex lens. So m is equal to minus di divided by d naught, that is equal to 30 divided by 7.5. 30 divided by 7.5, so m is equal to 4. Now in B part, in this case of concave lens, we can find the value. First we get the distance of image. Now 1 upon f is equal to 1 upon d naught plus 1 upon di. This implies that 1 upon di is equal to 1 upon f minus 1 upon di. That is equal to 1 upon minus 10 plus 1 upon 7.5. 7.5 plus 10 divided by 10 multiplied by 7.5. So this implies that 1 upon di is equal to 17.5 divided by 75. Taking reciprocal on both sides, di is equal to minus 75 divided by 17.5. So di is equal to minus 4.29 centimeters. Now we can calculate the magnification. M is equal to minus di over d naught. That is equal to minus into minus 4.29 divided by 7.5. So minus minus plus 4.29 divided by 7.5 is equal to 0.572. So magnification is 0.572. Now in next question, question number 16, given statement, Galileo is going the way of using the magnifier with the focal length of 3 centimeters. If here near point at n 25 centimeter, calculate the maximum magnification she can get. Now, first of all, write the given data. Focal length f is equal to 3 centimeter. Near point of the distance n is equal to 25 centimeter. To require that magnification m theta, so for the maximum magnification, we have m theta is equal to n divided by f plus 1. So 25 divided by 3 plus 1 is equal to 8.33 plus 1. So answer is 9.33. Hence the maximum magnification is 9.33. Now toward the last numerical, a television has magnification of 40 and the length of 12 1230 millimeters. What is the focal length of the object and eyepiece? So, first of all, write the given data. Magnification of telescope of m theta is equal to 40, and the length of telescope L is equal to 1230 millimeter. Now we can require that the focal length of object f naught and the focal length of the eyepiece fe. So both are calculated. First of all, find the solution. We knowing that the magnification of telescope is given by m theta is equal to f naught divided by fe. This implies that f naught is equal to m theta fe. So putting the values in given formula, so L is equal to m theta fe plus fe. Taking FE common in both sides, then L is equal to M theta plus 1 into FE. This implies that FE is equal to L upon M theta plus 1. L is equal to 1230 divided by 40 plus 1. FE is equal to 1230 divided by 41. So the answer of FE is equal to 30 millimeters. Now we can calculate the value of F naught, that is equal to M theta FE. So 40 multiplied by 30, then F naught is equal to 1200 millimeters. Best of luck. For more information and more questions, subscribe my channel. Best of luck.